In this video, I'm going to show you exactly how you can move data from any API within Airbyte using our brand new AI Assistant feature. Now let me put you through a scenario that might make more sense to you. Everyone has hobbies. I have my own, and personally, I am into the Pokemon trading card game, and for me, I like to invest in it, which means that I like to track the prices pretty much daily. And so I actually have an API that gives me that data, it updates daily, and I want to move that data and utilize it within a chatbot so that every day when I wake up, I can ask if any prices have changed, keep track of it, and see when I can make some form of investments. And that's where the AI Assistant feature comes in. I can give it the URL of my documentation, it'll scrape the documentation, create a connector within the Airbyte platform for me, and within minutes, I'll have a working connector that's sending data from the API to wherever I need it to be. So enough talking, let me show you exactly how I use the AI Assistant to move data from that API, and then created a chatbot on top of the data within PGVector to then prompt it and give me some answers back that I can make a decision with. All right, so I've logged into my Airbyte workspace on Airbyte Cloud, and what I'm going to do first is simply head over to the builder icon to the left-hand side, and here is where we will create our custom connector using the connector builder and the AI Assistant feature. If we click on the new custom connector button on the top right and click the start from scratch button, the use AI Assistant will be prompted immediately. And as you can see, and let me preface first, is that we are in a beta of this, so don't expect 100% results. But I do want to preface that we are currently in a beta, so there will be bugs, but please let us know in the comments or on Slack if there are any issues that you come across, and so that we can address them appropriately. Now, with that being prefaced, let me go ahead and input my information. So I'm going to go ahead and name this. So I'm going to say Pokemon TCG. The second thing I'm going to need is my API documentation URL. I already have it copied, so I'm going to go ahead and paste that here. And obviously, this is going to look separate from you, depending on which API you choose to use. Optionally, if you have the OpenAPI spec URL, you can go ahead and put that here. On the bottom row is going to be the first data stream or the first endpoint that you want to use for this custom connector. Again, this is going to be very specific to your API that you're using. For me, the first stream that I want to attack is going to be the cards endpoint. And so I'm going to go ahead and input the cards and then click create. Now AI is going to do its magic, and what it's doing under the hood is essentially scraping through the documentation that you provided and finding all the necessary information that you need to create a connector within the Airbyte platform and start moving data via the API. And realistically, and I can show you that in a second once we're loaded in here, what exactly the AI Assistant pulled for me. The first thing is obviously we provided the API base URL, but secondly, it pulled in what type of authentication is needed, and authentication varies across a lot of different APIs. APIs do them very differently. As you can see in this dropdown, sometimes you don't need auth at all. Sometimes if it's an API key, a bearer token, basic HTTP or OAuth, session tokens, those all are just very different across different APIs. But in this case, it sensed that from the documentation that we need an API key. It injected it into the header and what header name was needed in order to actually authenticate to the API. With that, I actually was given a testing value, and from here you can see that I need to generate an API key. And then I input that into the testing value so we can test essentially this connector. Now you'll see on the left hand side here there is a card stream. If I go ahead and click that, you'll notice that we have the URL path that it detected. You detected that it's a HTTP method, and our response format is going to be JSON with a primary key of ID. Down one more on the record selector, it noticed that the field path we needed to tap into was the data field path. Down below, if there are any request options, it would have populated here. And now, like I said, at the beginning of this is a beta, so it may not detect everything. I know that there are request options for this API, and so I will input those manually, but the AI Assistant didn't find them here. So again, just note, we're in a beta. It may not detect everything, so just be wary. Going down a little bit more, and which is pretty important here, is pagination. And pagination, again, differs from countless APIs, and we all know how difficult pagination can be. And so here it actually detected that we use a page increment. There's a page size, and then what start from page we want to do. It defaults to 1, and it'll actually inject that via a query parameter into the outgoing HTTP request. Now we can change that, but we don't need to, since that's exactly what we need. We can also inject the page size. I know for this specific API, there is no limit parameter where I can limit the response I get back from the API, and so we can inject page size into it if we want to modify this, max being 250. If I, for reason, wanted to do each page size, I only want 100 records, I'll go ahead and do that. And I know that the parameter is going to be page size in camel case, and it'll inject it in a query parameter. So these will be my outgoing HTTP requests when it comes to pagination. And down below, I didn't notice anything else that I needed. And to be honest, I don't need any of these other options via the stream. But one thing I will show you is that this is just the cards stream. And now if I click this plus button on the streams and go ahead and click this drop down menu, it'll actually note any suggested streams or other endpoints that you can attach to this connector. And so it's noticed a bunch of other different endpoints, the abilities, the attacks, rarities, resistance, sets, types, all the different stuff from this API. We don't need these, but it's nice to know that I don't have to go back and read the documentation again in order to add this. For this demo, I'll go ahead and add the sets endpoint and click create. It'll go ahead and scrape down through just that endpoint alone and fill out the information that I need. And so as you can see here, it filled out the URL path. Again, we have no request options here, but then pagination filled out. So again, exactly the same, but it is specific to this endpoint now. All right, so we're back to the card stream, and let's actually go ahead and test this endpoint out. What I can do is, as I mentioned before, in the testing values, go up here to the top right hand, and in the API key section, I'm going to go ahead and paste my personal API key for this. And once I save that, click no here, I can actually run a test on this stream and see what I get back. Once it was done running, you can see that I actually get some data back from the API, and I have a bunch of columns to work with in this response. And what we're curious about in this specific example for me is going to be these two columns here being TCG player and card market. Within these are going to be the prices that I actually need in order to prompt my chatbot for it to scrape through this and let me know certain things I ask it, but use this as the context. You can even see the request, the response in full JSON format. It'll auto detect the schema for you. So it'll declare that and use that for the connector here. If anything changes, you'll be notified. So all good there. I don't have to worry about that when APIs do change, and we all know they change often. Now, although this is cool, for me, I know that this API returns a lot of records because there are a lot of cards out there. And I noted that there is no limit parameter for me to utilize for this API to reduce the amount of records I get back. So I did mention that there is no limit parameter for this API. So what I'm going to go ahead and do, and note again that it didn't pick this up, but in the request parameters, I'm going to go down here and add the key parameters or the key value pairs for the query parameters. And I know that if I add Q for this API and I do name Charizard, that I will only get back cards with the name of Charizard. And so if I go ahead and run a test on this, I should only see cards with the name Charizard on it. And that right there has already limited me a lot of records. So I know that this is the data set that I want to work with, and we're going to go from there. Now that we're done with this, I'm going to go ahead and actually publish this connector to my workspace. So I'm going to go ahead and ignore the warnings here because we are not using the set stream, but that is okay because we don't need that currently. And I'm going to publish this to my workspace. So I'm going to go ahead and publish it. You could add a description if you want, but now you can see that the Pokemon TCG version 1 is now usable in my connectors. So let's go ahead and exit the builder, go to my connections. We're going to create a new connection, set up a new source. In custom, you'll see that the Pokemon TCG connector is now here. I'm going to go ahead and click that. I need my API key, so let me go ahead and grab that, paste that in here, and then click setup source. It'll run a check with the API key, make sure we get a 200 back when we make a call. And if it checks out, we'll move over and then set up a destination. All right, so all connections have passed, and now we're gonna set up a destination. I'm gonna actually set up a new destination and set up PGVector. Now there's a lot of different solutions out there, even local ones that you can spin up to set up PGVector. And if you haven't used PGVector, I highly recommend it. Really good if you're doing anything via AI. But in this video, I'm actually going to use Supabase. Supabase is pretty easy, open source, so fits the mold really, really well. And it's really easy to use when it comes to PGVector, especially enabling it. And so let me go ahead and do the chunk size here. So chunk size, I'm just going to go 1,000 here. Nothing I need right here in the text splitter or anything like that. For the embedding, we're going to use OpenAI. You have other options here. You can use Cohere, a fake one if you're just testing, Azure OpenAI, or anything OpenAI compatible. I'm just going to use OpenAI and then paste in my API key. Grab that. And then for the host, let's switch over to Supabase and show you exactly where you can go to grab that. So I've already made an account. You can create an account pretty easily if you have a GitHub, but here we're in the dashboard of my project. And I'm going to go ahead and scroll down, and on the home page of it, you'll actually see a project URL and the API key. We don't need those currently, but we'll come back to that later. Inside of the database tab, go to the extensions on the left-hand side, and you want to make sure that Vector is enabled as an extension. That is is essential, crucial, absolute requisite for this video in order to use any form of vectors inside of Postgres, hence PGVector. So just make sure that this is enabled and you should be good to go. So what you'll want to do is go down into the project settings on the bottom left. And then from there, you can go on database in the configuration tab on the left-hand side. And from there, it'll actually give you every single bit of the information you need to connect over to Airbyte. The password, obviously, for the database is something that you created upon creation of the account and the database. So make sure you remember that, obviously, but that's going to be personable to you as well as everything here. So what I'm going to go ahead and do is copy and paste all of this over to Airbyte and get connected there. So let me go ahead and do that. After all of that is inputted, let me go ahead and click up Setup Destination, and we should be good to go, moving data from our API over into PGVector. And it's also worth noting that, again, like we filled in our OpenAI key here on the embedding section. So we do actually create the embeddings for you and then write them into PGVector or Pinecone or any of the other vector databases out there that we have connectors for. And if you wanted to learn more, the documentation is here on the right-hand side. Cool. So we are now connected with the API over to Supabase. It's going to select our streams and fetch the schema for us. And then from here, we're actually able to go into the table and the columns and essentially select what we do and do not want. So the only stream I really want is the card stream, and there's only a certain subset of things that I need. So we're going to click card market, this object I actually need with the prices. For identification purposes, I'll grab the ID as well as the name of the Pokemon there. The number, the rarity is something I'll also need, as well as the TCG player object. Now, all of the other properties of this stream will be omitted from the destination, and only the things I have checked will end up in the destination. Since it's a custom connector, I can really just only full refresh it. If I needed incremental syncs, then I would have done that on the connector builder level. I did not do that, but if you do need that, it is worth noting to add some incremental sync functionality within your API custom connector. Since I don't, and I should be all good here, I'm gonna go ahead and click next, configure this. I'm gonna leave this as manual. I could leave this on a 24-hour schedule so that way I have up-to-date prices, which, you know what, I'm actually going to leave. I'll go ahead and schedule this for every 24 hours. That way, every single day, I have updated prices. And with updated prices, every single day, I can ask my chatbot for up-to-date information and make some sort of investments if I need to or whatnot, but it'll make more sense once we have the chatbot running. And so I'll leave all this as is. I don't really need to name this since it's pretty self-explanatory, and I'll go ahead and finish and sync. Now, I've already done this, but you usually obviously let this run and it'll go into PGVector or wherever you've decided to send your data to. But I'm going to go ahead and cancel this and actually show you what it looks like within Supabase. All right, so we're back inside of Supabase, and I'm going to go to my table editor here. And on the left-hand side, you'll see that the cards table was sent over from Airbyte and now into Supabase via the PG connector destination. Now, if I click this, you'll see that we have a couple columns here: document ID, chunk ID, the metadata of the actual payload from the API, the document content, which is essentially the metadata but in text format, and then the actual embeddings, which is the vectors of the row here. So you'll see that all of this is going to actually be in vector format for you to use within OpenAI or whatever other LLM you are using out there. Now, that's how simple it was to move data from the API or any API over to PGVector or any other destination that you need, especially in an AI use case when you need embeddings. It's very useful to have the embeddings for you already in the vector database, so that way you can just focus on hooking this up to an LLM and start training your models. How do we actually do that though? So let me go ahead and show you what I've already created and how I connected it to Supabase to essentially create a chatbot and start asking it questions. All right, so I'm in my code editor now, and I've spun up a local file, simple Python file. And what I've actually done is I've utilized the Supabase Python Library, which is an easy way to hook up to the Postgres database that is in Supabase. Now, they do give you an option to use more manual ways to hook up to the database if you prefer that method, but the Supabase Python library is actually pretty simple. And so let me show you how you usually would do that. And in this, I actually import OS, and then from the Supabase Python library, I have the create client and the client class, this being the method obviously, but we have two variables here, the key and the URL. And I mentioned that in Supabase, if you go back over to the homepage at the bottom here, you'll have the project API. And so this is is where you'll get the project URL as well as your API key. Pretty self-explanatory not to share this, but what I've actually done is copied both of these. I made an env file, but you should probably do this inside of your terminal once you've created a virtual environment. And essentially what you want to do is export those keys so that way within your workspace you'll have access to them and not expose them when you want to publish them to production or something. But I have these two variables here with my URL and my key, and then we just call the client class and then create the client utilizing both of those to auth into. And from there we have access to the Supabase project as well as the database. And from there we imported OpenAI, and that's when we started creating embeddings. This first function here is going to be creating the embeddings for the question that you ask. We input the question as an argument there, and from there we call the embeddings create method, and then input the question as well as what model we want to use. In this case, I'm using the text embedding 3 small, which just came out recently. And then I return the embeddings that is created from the question. Those embeddings will then be obviously vectors. And what we want to do is take those vectors from the question and do a similarity search on the vectors that are already inside of the database via the embeddings column. But how do we do that? So in this get context function here, I simply put in the question again. And within that, we call the get question embedding question. So we want those vectors inside of this function. I then just create a results array, which is what we're going to use to push all the information from the similarity search into. This query variable is going to be what we're using to store essentially the query on the similarity search between the question as well as the database. And this RPC method is part of the Python library, but it's what allows us to call a Postgres function from the library within Python. And so what I've done here is I've actually created a function within Supabase called find related cards. And let me show you kind of what that looks like. So if I go over to the database, click functions here, go to the functions tab, you'll have a bunch of built-in functions, but the one I want is called find. I have a couple created, but find related cards is the one that I want, like here. And so that's the name of it. And within that, what I've actually done, if I go to edit function, is essentially I just select all of the columns from the cards table, and I want to order it by the embedding column found within the cards table that we saw earlier. And now PGVector has a couple ways that you can actually run a distance function within Postgres. And so this one is going to be a cosine distance function. There's a couple others that you can look up online, but this is the one that we're using for this video. And we're going to run that similarity search between the question vector, which is going to be the variable that we pass in. You can see up here in the top above the definition that we're passing in a question underscore vector argument, which is of type vector, into this function, and we're limiting it to 5 records here. Now, this isn't the full function here. If I go over to my SQL editor, you'll see there is a find related functions, and this is essentially what I put into their SQL editor within Supabase to create the function. So essentially what we're doing here is creating or replacing the function named find related cards, and you can see what's similar to a function kind of syntax. In the parentheses is going to be our argument that we pass into the function. And so that's going to be question underscore vector, and this is going to be of type public.vector. It's going to return to the table, and this is essentially the schema of our table that we have within Supabase. The language we want to use is going to be SQL, and then now the actual query itself within Postgres is going to be exactly what we just described. This is very crucial for you to have within Supabase in order to actually take the question embeddings that you created within your Python file and run them against your database. So again, very, very crucial. Now, one little edge case that I found while creating this demo was that in normal syntax, when using a variable in a Postgres function, you'd usually wrap your argument in a tick with the curly brackets like so, and that essentially would allow you to, or Postgres would see this as a variable within the function, or sorry, an argument within the function that you're going to pass in. Within Supabase, though, on their platform, this caused a lot of errors where it would actually turn the question vector argument into a type of string instead of a vector, and so it would bug out and throw some errors. And so what I actually had to do was pretty much omit that and leave the argument as is. Supabase will do everything on the back end to notice that obviously these two are tied, and this is an argument that we're passing in, and this will then leave it as a type of vector that we specified. So make sure that not make sure, but that is something that I found while making this. So just keep that in mind if you are in fact using Supabase. Anyways, enough of the rambling. So you see that we have this function, and so back into the code, we're calling the function here using the RPC method. We're passing in the parameter or the argument that we requested, which is question underscore vector, and the value of that is going to be the embeddings that we created from the question, and then simply just call the execute method. Now we need to do more than just run that search. We actually need to do something with the items that are returned back from us, because we are running the similarity search across the whole database, and that's 100 rows that we're running through. And so I ran a loop here. So for item in query.data, so we're reaching into the actual query object, or inside of the response object. We're naming a variable called card_metadata, and it's going to equal that item. And I just append it to the results array that we kind of listed there. And then we just return the results. So fairly simple. We ran the similarity search here within this function. We got back embeddings or results from that search, and we simply want to append that to an array so that we can use that to get a response from our chatbot. And that's what we're doing down here in this next function called def_get_response. We're passing in the question again, and we're using OpenAI's chat completions API to create that response. And what I'm giving is the model for one parameter, and I'm using GPT-4o mini. In the messages, I've told it to be a helpful assistant to answer questions about Pokemon cards and to only use the provided context to answer questions. So it can only use what we give it, and I don't want it to use any external information because I want it to be trained on the data that I give it. And on the user side, on the content, we pass in the question as well as the context, and then run the get context function with the question there, and that'll start this whole flow here, working its way down. The max tokens I give it was 150, and the temperature, you can play around with this number, but I give it a 0.7, and then we just return the responses. Now down here, I have my question. We could make this app even better, and we will in future videos by adding some sort of front end, and then also sending that data over to a dashboard to have better visualization of it instead of just having a chatbot on it. But the question I want to ask is, what cards are selling for under market price? It should have that available in the context. We'll pass the answer into this variable and then print it in the terminal. So let me go ahead and run that. And so it's going to go ahead and do its thing. Take a little bit, but it should be sifting through the context right now. And then bam, I get some responses back. And so it gave me the answer. The following cards are currently selling for under market price. You gave me one Charizard G card, its ID, the market price of it, and the average sell price on the card market right now, which compare these two, selling below market price. There's a Charizard VMAX out there, which market price is $24.52, currently selling on average around $24.65, which is selling above market price, but low. So you could make some sort of decision there. And then there's this Charizard here with a market price of $1 normal and $1.53 on a reverse. So still definitely some context there. Let's try another one. Let's see, show me cards that are selling for more than $100. So let me go ahead and save that, clear this, and run that again. So it'll run the similarity search across those embeddings, find what's similar. And here we go. We actually got some more information back on this one. The answer, here are the Pokemon cards that are selling for more than $100. Charizard base at 1, really cool card. It gave me back its rarity, the prices on TCG Player right now, which is going to be a low of 260, a high of 1500. The market right now is going for 412, so make it what you will. It even goes on the card market and tells me its average sell price, what low price, and its trending price right now. So whether I have this card or not, I could actually make a decision based off of this. And then it of course gives me a link to that specific card if I wanted to check it out. So that right there is how you can create a chatbot fairly simply, honestly, on top of PGVector using Supabase, feeding Supabase via Airbyte, via the AI assistant through an API. So this whole workflow is super cool. It's very, very useful, especially if you have an API and there's some decision making that you need. You want to utilize AI to make those decisions and make it easier to kind of like find the answers that you need. This is a perfect use case for that. Hopefully you learned something from this video. If you have any questions on anything regarding this, let us know down in the comments. But in the next couple of videos, we'll definitely be improving this project here for you to use. You can even find the code here within the description down below. We'll have it linked to the GitHub repo, and we'll have a lot more sample apps coming out. This will also just evolve, like I said, so stay tuned. Make sure you're subscribed so you can see any of the changes that we make to this project or when future projects come out. But that's going to do it for today. Hopefully you learned something. Let us know how we did down in the comment section below. But otherwise, I'll see you on the next one. Peace. Also, before I leave, make sure you try out the AI assistant. It is amazing. Use it across any documentation you want. Sign up for Airbyte Cloud right now. Give it a shot. 14-day free trial. Don't forget. All right, now for real. Bye.